IP router RIP, then network, blah, blah, some commands, then everything worked fine. But in this real gear, in the real hardware, I couldn't say that it would be like 40% of the time the case that everything worked perfectly. You would be wonder when everything worked perfectly. You would ask why everything worked perfectly. That must be something not true. Have you ever heard too good to be true?
Yes.
That's the case. When everything works on the hardware, you would hear this too good to be true term from this Keith Parker a lot. Every time that he hasn't any problem with any lab, he said too good to be true because it's real. It's real that this hardware won't work like the packet tracer. Packet tracer is written in a software, work perfectly, but hardware would never work like that. You just need to adapt that. You just need to learn that the hardware sometimes have really ridiculous problem that you must be faced when you want to work as a network engineer, administrator, or whatever you want to call it.
Okay, thank you very much. I'm gonna do something very unpolite and mute
On
everyone.
Wednesday,
Because we are gonna continue the next talk, and we are also already live on YouTube. So I hope you're aware of that. I think we're live on the YouTube again. Yes, seems so. So
okay.
Let's unmute Alan.
Should I do it?
Mm-hmm.
Okay.
Yes, you
okay.
Hello.
Hi, Alan. So I'll give a small introduction to who you are so people know who they're referring to and who's talking to them and who's presenting something. So our next speaker is Alon. He is currently a professor at the Humboldt University, a recent professor from the beginning of this year. He started his position at the Humboldt University. Before that, he was working at research labs in the industry at Zalando, IBM, if I'm not mistaken, and has completed his PhD only 5 years or 6 years ago, which is, in my opinion, very quick to advance to a full professorship. No, yeah, it is full. Yeah, exactly. It was a tenure track professorship. So I congratulate again. And he will talk about his Flare tool, Flare library, which is available on GitHub. You can check it out. There's a link on the meetup page. And he will tell us a little bit about NLP and how his Flare network and embedding is basically treating language. So thank you.
Yeah, thanks for the nice introduction. Maybe the first question, how much time do I have for the talk?
I think half an hour is it like, yeah? It's good, and then we have a question.
Yeah, so half an hour is okay. Yeah, I could make it a bit faster.
No, it's good. Like, take your time. Okay. I think it's good.
Okay, then let me share my screen, and thank you very much for the nice introduction. So can you see this?
Yes.
Okay, great. Okay, yeah, great. So I'd like to talk about the Flare framework, and Micha was very good with his introduction. So you basically allow me to skip my first slide because you said everything. What we do in my group at the university is we develop the open source NLP framework Flare. So, and this is really what this talk is about. To start at the beginning, so the development started in my previous company. So before I joined the university, I was at Zalando Research here in Berlin in the NLP research department. And the company actually had a lot of text data that we wanted to analyze. And for instance, we wanted to do named entity recognition on this text data. So Zalando, because I understand actually there's a lot of people who are outside of Berlin in this talk. So Zalando is actually a big fashion company in Europe. And so basically we had a lot of text data in the domain of fashion, like this blog post, right? And what we wanted to do is we wanted to identify words and groups of words that belong to certain semantic categories like colors or fashion items or like fashion brands, like this kind of stuff. So this is a fairly standard named entity recognition task. And there were different types of text mining that we wanted to do. But when we started our work, actually, we were kind of unhappy. So we looked at all the research papers or some of the research papers, and we were kind of unhappy with the general reproducibility of the research results that we were reading about, because they were talking about these great numbers, and it was somewhat difficult to reproduce. And so some of the problems that we had was, for instance, that some papers only report the results, but don't actually open source their code, right? So you see these great numbers, but it's pretty hard to actually reproduce them unless you sit down and implement it all yourself. But the problem here, of course, is that a lot of research papers don't have all the technical details, right? A special case of this is that some people say that they will release their code, but they actually never do. But it's the same situation. In the end, you don't have the code. Another thing that we encountered a lot is that code is actually released that belongs to a paper, but it's actually really hard to get running, right? So it's basically really hard to read, and it has a lot of dependencies. So basically, we kind of refer to this as fake reproducibility, because on the one hand, the code is there, but on the other hand, it's actually not super usable. And the final case was script produces number. So we encountered this a few times, that the research code is released and it does run, but then it's just like this massive script. You get the line that you have to execute, and it runs forever, and at the end comes out a number, let's say 42, that matches the number in the paper, but you really don't know what's going on, right? So we were generally unhappy with the reproducibility. And this is, I think it is slowly getting better. But generally, this is, I think, a problem in many machine learning disciplines, right? So for instance, if you look at named entity recognition today, or right now, if you look at the top 5 papers, I think 3 of them don't actually open source the code, so you can't reproduce it. So it's still a big issue, all right? So we thought, okay, so what are the desiderata for reproducibility? So what would we like? So this is all very obvious stuff. So we would like a very quick setup. So we would like the framework, the algorithms to be set up very quickly on your machine, but also to include all the data sets that we need in order to run the experiments. If the experiments require models, such as embedding models, they should all be included. So all of this should be there, right? We also thought it should be modular in the sense that the code should be easy to read, to understand what part of the code does what. And also make it easy to switch out components. So for instance, in NLP, you do a lot with embeddings. So let's say you have a research result that uses glove embeddings, and to make it actually really easy to switch out a different embedding layer, like a bird embedding layer in there, right? We also would like the code to be applicable to new data sets and tasks, meaning that the code should not have any specific assumptions about the data, right? So it should just be usable to take this research result and apply it to my task, right? And finally, it should be easy to build on top. And I mean, if you look at this slide, this is all super obvious, right? So this is no rocket science here. And if you do part of speech tagging and look at the adjectives on the slides, you're going to find the words easy used a lot, and the word quick, which in this case is a synonym for easy. So basically what we really wanted was research that is easy to reproduce, and also research that is easy to apply. And this kind of motivated us to develop the FLAIR framework. The tagline is a very simple framework for state-of-the-art NLP. And the 2 crucial parts are very simple, so it should be easy to use, and state-of-the-art, meaning that it uses recent NLP research and makes it applicable for everybody. Yeah? FLAIR is built on PyTorch, which is one of the most popular deep learning frameworks, and it's actually an official part of the PyTorch ecosystem. And it is very, very much an open source project. So it's an NLP library, but there's no company behind it. So we're not selling it. We're not making any money. So basically, the whole development of this project has basically been driven by open source community and contributions from a lot of people. So without the open source community, this project would definitely not exist and would not look any way like this. So what we originally open sourced 2 years ago looked very, very different from this. And it's actually the involvement of the open source community that trained new models and added features and fixed a million bugs that made this framework, right? We're currently at version 0.4.5, and we have a new big release coming this week. I wanted to have it done before this talk, but unfortunately, it didn't happen. So, but it's coming this week. Yeah. So what is Flare? So there's essentially two views on it. For most users, it's an NLP library. What it allows you to do is to use NLP models on your text. And there's a lot of models that we just include, and I'm going to show you a bunch of demos for some of the models that are included that you can basically just use as they are. Another thing that a lot of people do is they use the library to train your own models, because there's a lot of things like languages or tags that may be very specific to your use cases. And so the library makes it easy for you to train your own NLP models. And the uptake actually is tremendous. So thanks again to the open source community. It's used in hundreds of dependent open source projects. And I know a lot of companies are using it in this way. A lot of startups and medium-sized and even large companies are using it. The other point of view that's more relevant, I think, to the university where I'm at right now, is that it's an NLP experimentation framework. So essentially, there's a big focus on word embeddings and text embeddings in the framework, and standard NLP pipelines. And so essentially what you can do is you could develop a new word embedding or a new text embedding. You can plug it into the framework and basically run it in default NLP pipelines to see what the impact is on downstream tasks. So we include a lot of like standard data sets and standard pipelines where you can immediately see what's going on. However, on this talk, we're not going to talk about the research at all. Instead, I'm just going to walk you through the framework. I'm going to show you how you can use these models, and I'm going to show you, maybe time permitting, probably not, how to train your own models. Okay? Okay, so we're going to do a walkthrough together. Setting up Flare is very easy. Just like the previous project, all you have to do is pip install Flare. It requires at least Python 3.6. And you can do it, for instance, in an online environment like Colab. So it should be very simple to set up. And then once you have this done, you can actually already start tagging your text. One big task that we support is text classification. And in text classification, what you want to do is you want to take a piece of text and automatically detect whether it belongs to one or multiple predefined categories, right? So a very classic example of this is sentiment analysis. So where you want to detect, is this text written in a positive way or in a negative way, right? So if somebody writes, I really like this movie because, you want to predict that it's positive. And if somebody writes, I really hated this movie because, you want to predict negative, right? And text classification is actually super versatile. You can use it in a million different use cases. Another one is hate speech detection. This is a German example where you want to find out, like, is this speech hate speech? Is it offensive language, yes or no? And if it is offensive language, which type of offensive language is it? So in this example, du bist doch ein blah, 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 would be an insult, right? And in fact, it's very versatile. You use it for intent detection. You use it for many different use cases. And what I want to do now is I want to show you a demo of one of the taggers that we have in Flare in action for sentiment analysis, right? So I'm going to try this. I'm going to exit this. So the first question would be, can you see this? Can somebody, I don't know, Micha maybe?
Yes.
Okay, great, thanks. So what we're going to do is we're going to enter some sentences and we're going to predict whether the sentiment is positive or negative, okay? So I'm going to start with, this talk is interesting. I'm going to be optimistic. Okay, so if somebody writes this, I click on the sentiment. And what we can see, so I have two sentiment models. One is transformer-based, which is the better one. And one is an RNN-based model, which is the faster one. So they're both packaged in Flare. And as you can see, I hope you can see it, this talk is interesting, was classified as positive by both models, right? If I now go ahead and say this talk is not interesting, I do the prediction, and now both models actually very clearly say this is negative because it's a very simple example to classify, right? To maybe show you a more complex example, okay, let's say we use something that's a little bit sarcastic, right? So we say this talk is about as interesting as watching paint dry. So it mentions interesting, it doesn't mention not, but it says it's about as interesting as watching paint dry. So in this case, what the models tell us is that it's a negative, right? So because this is an expression you use in English to say something is boring, right? This word is actually a giveaway, this about. So if I remove this and I just say this talk is as interesting as watching paint dry, then I do the sentiment detection. As you can see, both models still tell us that it's negative, but the confidence has actually dropped from like 99% to very low confidence, 50%, right? I'm going to do another one. I'm going to do this talk is as interesting as watching, let's say, a baseball game. If I write this, now both my models will tell me that it's positive because our models seem to believe that baseball is interesting, okay? And of course, you can do this with real data as well. So I have a newspaper article here. And if I put this in, this is from a newspaper article, you see that this statement, which says something bad about the economy, is classified as negative, right? So to go back to the talk. Okay, so you have this type of model. So let's say you want to use it yourself for your use case. So basically, this is the full code that you need to do it. As you can see, it's only like 3 or 4 lines of code. The most important one is this one. So you do text classifier .load sentiment. The very first time that you call it, it will download the pre-trained model to your machine. And if you run this code again, it doesn't do that download again. So it only does it on the first call and puts it into the object. Then you put your text into a sentence object. You always have to wrap your text into this object, which allows you to do like a bunch of cool stuff. And then all you really need to do is call tagger.predict, and then you can print the labels. So it's just a few lines of code, and then you know whether this piece of text is positive or negative, right? Another task that we support a lot in Flare is sequence labeling. So I had an example in the beginning of the talk. The most famous one is named entity recognition, where you want to identify the names of people, names, what they are. Are they names of people? Are they names of locations? Are they names of organizations? Or you want to go into the words and identify in part of speech tagging, what are the verbs in the sentence? What are the adjectives? And again, there's a lot of different use cases why you would want to do something like this, right? And maybe to quickly show you a demo of this as well. So this is now the sequence tagging demo. I'm going to show you a few different models. I'm going to start with a simple sentence.
While you type, I want to read out the question. I mean,
Yes.
People are asking, where are the models downloaded from?
So the models are stored on like an AWS bucket. So basically, yeah, they're just downloaded from there.
And it's something connected directly to Flare. It's like something that Flare basically manages.
Yeah, exactly. So this is managed in Flare. So basically internally it checks if the model is already on your hard drive. So there's like a standard folder where all the models go. And if the model is not there, it'll download it from the web. And this is actually not only for the models, this is also for data sets, for instance. So Flare actually includes a lot of different data sets and also word embeddings. So basically everything that you need, there's this logic, it checks if it's there. And if not, it'll download it to your machine.
Mm-hmm. Okay, interesting.
Okay, cool. So to maybe show this sentence, George Washington was born in Washington. That's, by the way, not true. I'm pretty sure it's not true, but I use it anyway. To do named entity recognition on this sentence will tell us that George Washington is in fact a person, these two tokens together, and Washington is a location, right? It's also fairly robust, which is kind of cool, which is why I used this example. If I say Washington was born in Washington, it'll still know that the first Washington is a person and the second Washington is a location, right? To show you the difference between named entity recognition and part of speech tagging, I can also just use part of speech tagging. And now what I get is the syntactic type of each word in the sentence. For instance, I know that born is now a verb. And this can be useful for certain things where you want to extract information like what kind of adjectives are being used, what kind of verbs are being used, right? To go back to the presentation. So let's say you want to do any of this, you want to do a named entity recognition, or you want to do part of speech tagging. This is the code snippet, and you might notice that it looks extremely similar to the one that I showed you before. That's because there's only one line that's different. And the different line is this one. So you're going to load a different tagger, obviously, right? So this time you're going to type sequence tagger.load POS for the part of speech tagger, or load NER for the NER tagger. And again, the same logic is called. So it downloads the model on the first call to your machine. Then again, you're going to make a text object for the text that you want to classify. And then you're just going to call tagger.predict on the sentence, and that'll predict whatever tags the model is trained to predict, right? So that's two tasks. That's text classification and sequence labeling. So another thing that I'd like to show you is one model, many languages functionality that we have in Flare as well. So basically in NLP, what you typically have is you have models that are language specific. So you might train a model to do NER for English. You might train a separate model then to do NER for German, right? And this basically means that you always have to do a language detection first to see which model you should use, right? But it's actually possible to train a single model using training data from multiple languages. And especially if we use multilingual language models, which we have in Flare, right? And what then happens is that the language identification becomes implicit to the model. So you can actually just give it text in any languages, and it'll just be able to kind of deal with it. Yeah? So I want to show you a demo of this as well. I hope it's not demo overkill. No, that's not good. This works. This doesn't. Okay, this works. Okay, so I hope you can still see everything. So we go back to the part of speech tagging example, right? So we said George Washington was born in Washington. And we know born is a verb. Let's add a different language to this. Let's say George Washington wurde in Washington geboren. Yeah? Same sentence in German. So I'm gonna parse this with the multilingual model now. And what happens is that even though it's the same model, seeing text in different languages, it's able to predict correctly that geboren is a verb and born is a verb, right? So it can handle this, right? Another example, let's go into my, I'm not super sure. IT, nee. Somebody correct me, please. I think this means George Washington was born in Washington in French, IT, nee. If I do this tagging again, at least nee, I'm pretty sure that means born is tagged as a verb. Okay, so you can actually deal with these models with text in many different languages, and that can make, depending on your use case, if for instance you have, I don't know, for some reason you have a website where people enter text in all sorts of languages, this could be useful for you. Okay. Oops.
There's another question on YouTube by Zeki, and he asks, how much data is necessary to train for different languages in this Flare model? I assume it's the Flare model.
So, I mean, it's always the more data you have, the better. So standard data sets for sequence labeling tend to be around 12 10 to 20,000 sentences that are annotated. I think there's some data sets that have less. So generally, I mean, it's always the more data you have, the better. At least, so with the universal dependencies projects, there's actually pretty good data available for part of speech tagging for many different languages. If that answers the question.
I think that should answer the question. Maybe another question that might be interesting. For multilang, must languages be from the same family, or does it hold, say, between Finnish and Portuguese?
Yeah, so Finnish is actually funny because it's, of course, a super crazy language. So we, in this paper that we have here on the slide, we trained it for 12 languages. And I think Finnish was actually the hardest one of all of them. So the other ones were from at least the same language groups. So like Romance languages, Germanic languages. So it's of course helpful if there's if they are in the same group. But if you have sufficient training data for each language, you can still train a single model that works across all these languages. So even Finnish doesn't work. It's pretty good. So it's not a must.
Okay, I think we'll continue with the presentation. I'll ask some more questions that are posted on YouTube and in the chat later on.
Yeah, sure. Okay, so this is maybe I wanted to give a small list of some pre-trained models that we have in FLAIR. So obviously I already showed sentiment analysis. I've showed, oh, I didn't actually show the 12 class named entity recognition. So this is 12 class is basically just more classes. So not just person, location, and organization, but even more. There is part of speech tagging for many different languages. We have something called semantic frame detection, syntactic chunking, and we have multilingual models. And I think there's also models for stuff like hate speech detection. So essentially, this is just a lot of models that we ship with FLAIR. Some of them were trained by us. Many were also trained by the community. And so through the open source community, this list is growing and growing. So we are supporting more and more languages with this kind of stuff. So, so far we've seen text classification and sequence labeling, but we also have a few other NLP tasks that are currently kind of beta. One of them is text regression, which actually is pretty stable already. So essentially, in this case, you don't want to predict a class label, but you want to predict like a value, like 80% or like on a spectrum, right? So how happy is this person? Or how unhappy is this person? This can be useful depending on your use case. And so we already have the architecture in FLAIR, so you can train your own regression models. And we also have some data sets that we already ship with FLAIR. For instance, the VASA 2018 shared task that is data that is annotated with joy, anger, fear, with certain emotions on a scale from 0 to 100, okay? So you could train, we've done it, you can train models that predict how angry a person is, just from the text, right? Another thing it's very, very beta, but I'm very excited about this, is similarity learning. So here, what you want to do is you have 2 data points, and these data points could be 2 texts, but they could also be a text and an image, which is what we've been working with. And you want to learn how similar they are. So essentially something like an image like this dog catching a frisbee should be very similar to the text dog catching a frisbee in the park, right? And for this, we include currently one data set, the PyData data set that we actually developed also, which is fashion images. So this is still from the Zalando time, in German language descriptions. So, but this is very beta stuff. So we hope to develop this more because I think similarity learning is actually really exciting and there's a lot of cool things that you can do with it. So here and with all things, I'm very happy to collaborate with people. If anybody's interested in any of this stuff, we're always happy to collaborate since this is very much an open source project. So what is the time?
You have another I would say 5 to 7 minutes.
Okay, then I'm going to skip over how to train your own model because it's something we have tutorials online. You can just check it. Just take my word for it that it's fairly easy to do. Yeah. So let me just skip over that. Maybe just to show you the very last slide of that portion. So this would be a full example of how to train your model. So I'm not going to go through the lines one by one, just to show you it's only a few lines of code. And it's fairly easy to do. And we've seen a lot of people also with very limited background in Python, even in Python, who managed to train their own models. So it's very, I think, very easy to do. To conclude then, so I introduced the Flare NLP framework. So I showed some NLP tasks, specifically classification and sequence labeling, which really are the big tasks that we've been focusing on. I demoed some multilingual models, and I showed you some code snippets for predicting and training that hopefully convince you that the library is in fact quite easy to use. There is a release coming this week, I promise. It will include a lot of new embeddings, new data sets, new pre-trained models. It will include for the first time fine-tunable transformers, which work really well and really have increased the accuracy for the text classification part. And there's a lot of refactorings and simplifications of the code that we've done that will be part of the next release. The immediate future will be more. So what we want to do is, so we want to actually add more tasks. So next to just these 2 tasks that I've demoed, we're interested in branching out to things like relation extraction, semantic role labeling, information retrieval in the context of similarity learning. So basically, we just want to support way more tasks. And we feel that it's actually possible to do it now, because now with my new job at the university, the manpower situation is looking very different. So I think I've met a lot of very interested students, and I'm very optimistic that we can actually get a lot of things done now that previously we couldn't because we just didn't have the manpower, right? We want to include a lot more data sets and languages and apply it to new domains. We have a project already running called HuntFlare that will be released hopefully soon, that will just include a lot of new data sets and expand Flare to new domains. And we're kind of excited about adding new data types like images or even complex types that are kind of combinations between text and images or semi-structured data. So this is kind of a maybe, but I would be very interested in doing this as well. There's a lot of research that, of course, we're working on at the university. So this talk was really a focus from the practitioner point of view. But of course, what we do, our day job, is research at the university. So we have a lot of fancy neural language models that we want to develop, so a lot of crazy ideas for word embeddings that we want to put in there. We want to work more on this multilinguality aspect. And there's a lot of research in terms of hyperparameter selection and neural architecture search. So I just broke this S, and I'm going to fix that because that's important.
Since we're here at the spelling mistake, there's a question on YouTube regarding the typos and the correct spelling in the Flare embedding and the Flare model. What would happen? How would Flare react if the words were spelled incorrectly?
Yeah, that's a great question. So essentially, the answer depends on the embeddings that you use. So our own embeddings that we developed are character language embeddings, and they tend to be fairly robust to spelling errors. But of course, it all breaks down. So not sure which demo I can use best to show this. Let's say let's use this demo. Let's do this, right? See what happens. And for some reason, it still is able to see that this is a location, right? If you guys can see this. So of course, at some point, everything just goes goes crazy. So if I do something like this, well, okay, that still works for some reason because born, I think this is a very good, let's do something like this. Okay, that still works. Okay, so it's fairly robust. So and the reason for this is that the language models that are powering this, at least the FLAIR language models, are at the character level, meaning that they see words as sequences of characters and are therefore able to do a lot of guesswork, right? If that makes sense. So it's, but yeah, it's fairly robust.
Yeah, I think that answers the question perfectly. Maybe another question to slide that you showed before. There's this question regarding the RNN and transformers that you loaded and you used to do the sentiment analysis, if I remember correctly. Are they both implemented in FLAIR?
No. So basically, for the RNNs, we just use the default RNNs that come with PyTorch, and the transformers we completely rely on the Hugging Face transformers implementation. So yes.
Okay, thanks.
Okay, then maybe to wrap it up. Yes, so I just fixed the join us because that's a very important part. Yes, as I mentioned before, so this is an open source project. There's no company and nobody's making money. So this type of thing really lives with people getting involved and people becoming interested to contribute to the open source project. So I would like to invite everybody to join us through the open source project. If you're interested also with collaborating with my group at the university, we're very open to any type of collaboration. Right. And so this is it. So we've already had questions, but maybe there's more questions. Thank you.
Okay, thank you very much. There's another question that I see. It's from Drol, and he is asking if these models are ever updated, if they're like, how are they trained? Basically, if you train a model, is this model ever retrained in a sense?
So you have the option of retraining it. So essentially, I mean, the classic pipeline would be that you train it over your training data and then you just have the model. But what is possible is to take an existing model and continue training it if, for instance, new training data comes around. So for instance, I know some people are using it in an active learning type scenario where you add new training data points over different iterations. And in this case, it's possible to essentially continue training a model. So the training could never be seen as complete in a sense. So you can always continue training it if you want to.
Okay, cool. There's another question on YouTube. How would you decide whether to use TensorFlow or PyTorch?
So I think, I mean, this is 2 years ago. So, but at the time, at least, my personal opinion was that PyTorch was way more usable than TensorFlow. And in fact, it was actually before TensorFlow added this eager mode functionality. So a lot of the things that we are doing in FLAIR would not have been possible with PyTorch, with TensorFlow back then, because we use these dynamic computation graphs actually a lot.
Okay, cool. I don't see any further questions, I guess. Oh yeah, there's another question about the French language. Is there any model in entity detection, entity recognition, relation extraction in this open source project?
I think we have a French NER. So we definitely have a French part of speech tagging model. And I'm pretty sure we have a French NER model as well. So French is definitely included in the multilingual models. And I think we have dedicated models for French as well. So French was not trained by us, but it was trained by a community member, but I'm pretty sure it's there.
Okay. Is it possible to examine a whole passage or a conversation, not only a sentence, to decide positive or negative sentiment?
It's generally possible. So with transformers currently, actually, it's not with a transformer-based model because the transformers have a maximum sequence length. That's a hard restriction. If you use the RNN-based model, it is possible. Personally, so we've trained the model with passages of maximum 50 words because I kind of feel like at some point, if your text is long, there might be multiple sentiments, right? So the newspaper article that I just very briefly showed has some positive news and some negative news. So I think it would be kind of hard to say this. I mean, you can probably still say it, but I feel like it's actually maybe more useful to, if you have a big text, to chop it down into paragraphs or sentences and just then do sentiment analysis on each one of them to get your results.
Okay. There are a couple more questions. I think we should start with the question about Flare versus Spacey. What's the difference? Why should I use Flare instead of Spacey, for example?
Yeah, I'm not super happy with this kind of question because I actually don't. Yeah, so I don't have enough experience with working with Spacey myself to answer this question very well. So the last time I answered it, I ended up saying something that was actually wrong about Spacey. Generally, I think you should work with Flare if you like the type of abstraction that we have. So basically this idea of having access to a lot of different word embeddings that are coming out of research right now, and you want to apply this research immediately to your projects. But at the end of the day, I think it comes down to preference. So the abstractions that you like, the functionality that you prefer, it's a bit hard for me to give a good answer to this.
Okay. There's another question about, again, by Dror. This is from the Meetup chat. Whether the security of these public models is an issue. I mean, basically, you could edit the data or create some data that will train in the sense that, well, some president candidate, and this will map to negative sentiment. Is this an issue?
Yeah, I mean, so if you, for instance, if you manipulate the training data in such a way, you could bias the model. So that's possible. So in our case, we've used just publicly available data sets for sentiment analysis. So in this case, it's basically, for instance, the data that we used was trained on Amazon reviews, product reviews, and movie reviews. So, and there's going to be biases in that data, and these biases will be in the model as well. So, yeah, that can happen.
Okay, but Flare doesn't really curate the data itself. I mean, there is no part of Flare that specifically is responsible for curating the data and being responsible in a sense, or like having some quality measures for the data set that is used to train the model.
No, so basically the only curation we do is to kind of try to filter out low quality data points. So basically, there's always noise, especially in these data sets. So we do filter out noise, but we haven't really looked into like this type of political biases or this kind of stuff. But we're interested. So if somebody's interested in doing that, that would be great.
Okay, I would say that I'll read another two, or I think I only see another two questions on YouTube, which is geared towards the GPT-2. And it's just a general question. What do you think about it? What do you think about GPT-2?
Yeah, I don't know how to answer that question. It's
Okay.
impressive work. So I think we included also it's also included via Hugging Face transformers into Flare. I have not experimented too much with it. So because we actually have a lot of like different embeddings. So with GPT-2, I haven't really worked too much. So I can't really say too much about it.
Okay, and I think the last question, if I, oh yeah, that's, I think, a question regarding, again, the sentiment analysis. You had an example that was basically one of these borderline examples where you can't really fix the sentiment one way or the other, where you had like this 51% towards negative. Why isn't there a neutral sentiment?
The original model, we actually had a neutral sentiment. It's in the end, I removed it because there was too much noise in the training data. So this is really just a problem of the data set. If you have a data set that has a good neutral category, then that's great. So essentially, to go back, so the sentiment data for the most part is trained over Amazon product reviews, where people give between 1 and 5 stars, right? And so the problem is that if people give, for instance, 3 stars, the language use is actually extremely different. So some people will say 3 stars, that's pretty good. And some people will give 3 stars if something's completely terrible. So the model was actually having differences just because the signal wasn't that great. The model was having a lot of problems trying to find out what neutral actually is, if that makes sense. So in the end, what we did is we actually only used 1-star and 2-star reviews as negative and only 5-star reviews as positive, to just have a better separation of language of what these two things are. And then we kind of say that because the model always outputs a probability or like a confidence value. For instance, we've seen that the confidence in this one example was very low. And then in your use case, you could say, if the confidence is not so high that it's either negative or positive, then I'm just going to treat this as a neutral, right?
Okay, maybe one last question, which is geared specifically towards you, and then I think we'll thank you, and because it was a really great talk. How can I join you, Alon, via LinkedIn? Question mark.
Yeah, sure. Hit me up on LinkedIn. That's totally fine. Join the open source community. That's the easiest way. So like I said, so we're happy to work together with anyone that we can. So
okay, in that case, I want to thank you, and I think the entire PyData group that is here on Zoom and also on YouTube is, I think, very happy with the talk, and it was very interesting. So again, thank you for talking. Noah, do you want to say something? Noah?
Yeah, sure. Thank you everyone for coming. Our next meetup will probably also be online on June 17th. So we had two mysterious, we had the contest that we announced in the beginning of the meetup, and we had 2 contestants from Chile, but they haven't emailed us yet. So, and we have been contacted by the attendee from Argentina. So now he's the front runner for getting the amazing PyData stickers. Please join us again. You can find us on Meetup or on Twitter, and we also have a website which we can quickly post on the YouTube chat for people who are not familiar with PyData Berlin. Matti, I hope you're doing it quickly. Yeah, and have everyone a very nice evening. We have also recorded the talk, and they will be published sooner than later.
Okay, so I guess that concludes our PyData meetup, and we'll see you next time. Okay, bye-bye.
Bye, everybody.